All right, this is day 2 of our unit on solving systems of equations. We're just going to be practicing a little bit more with our substitution and elimination. Now, for this assignment, you were allowed to choose whether you wanted to do substitution or elimination. So, it pays to stop and think. For elimination, we need all the terms sort of lined up. We can always rearrange things, so that's something to think about. For substitution, we need to get one variable by itself. So for this particular problem, we really could do it either way. So let's see. Say if I want to do this by substitution. I like to write the problem sort of side by side when I do substitution. So what we would have is, so we've got this equation, which I'm just going to leave the way it is. All right, but putting this equation up next to it, I have negative 2y is equal to x plus 4. Okay, so now I've sort of moved it over. Okay, now the first step of substitution is to get one variable by itself. So I'm going to go ahead and get this x by itself by subtracting 4 from both sides. Okay, so that's going to give me negative 2y minus 4 is equal to x. Once you have one variable by itself, you can take the stuff that it's equal to and substitute. So this should go here where the x goes. All right, so that is going to become, maybe I'll plug it in over here. Okay, so if I've got this 14y minus x is equal to 4. Okay, if I'm taking this and plugging this in, this is going to be 14y minus parentheses is equal to 4. Now, what is going to go in those parentheses? Well, this stuff. All right, because I'm taking this and I'm plugging it in. Okay, so I'm going to put my negative 2y minus 4 in for x. Now, the parentheses are very helpful because hopefully they will remind you that you need to do the distributive property right now. See this minus sign? You really want to treat it like it is a negative 1. Okay, so negative 1 times negative 2, a negative times negative is positive. Negative 1 times negative 4 is a positive 4. So then we'll have bring down our 14y plus 2y plus 4 equals 4. All right, you must distribute the negative sign, and that's going to become a positive 4. Now we have like terms. These are like terms, so that's going to give me 16y plus 4 is equal to 4. This is a little bit strange, but don't be scared. If I want to get y by itself, the next thing that's going to happen is I would subtract 4 from both sides. Okay, but if I do that, what's 4 minus 4? That is 0. Now, does that mean this is no solution or something? No, it does not mean that. 0 is just a number. So just treat it like any other number. And we keep going. To get y by itself, we need to divide both sides by 16. Okay, so that is going to give us y equals 0. 0 divided by anything is just 0. So far we know that y equals 0. Nothing wrong with that. Now, we still need to find x. So to find x, all we have to do is take this y value and substitute it back in. All right, if I do that, I'm going to get negative 2 times 0 minus 4, and that's going to give me x. Well, negative 2 times 0, that's just 0 minus 4. So that just means that x is equal to negative 4. All right, so as an ordered pair, we would have -4, 0. So that should be the answer to number 1. All right, let's take a look at number 2. Since x has a coefficient of 1, there's no visible number in front, this would be pretty easy to get by itself. So that is what I'm going to do. So to start off with, we have our two equations. So we have our x plus 4y is equal to 8. All right, and then we have our 3y is equal to 5 minus x. Now for me, this x value right here is the easiest one to get by itself, because all I have to do is subtract 4y from both sides. So that is going to give me x equals -4y plus 8. So now that I have x by itself, I can take this and substitute it in for x right here. Okay, so this is going to become 3y is equal to 5 minus parentheses. Always use parentheses when you're doing a substitution. And of course, inside the parentheses is this, -4y plus 8. Now, just like the last problem, treat this like a -1, and you're going to have to do the distributive property. So, a negative times a negative is a positive. So this is going to make positive 4y and -8, like that. So we will have 3y is equal to 5 plus 4y minus 8. Now look, these are like terms, the 4 and the -8. Okay, the 5 and the -8. 5 and -8 together make -3. So we're going to have 3y is equal to 4y minus 3 by putting these two together. Now look, I have y's on both sides of the equation. I need to get them together. So whenever you see a variable on both sides, you should subtract one of them to get them together. So if I do -4y, I'm basically trying to move this over here by canceling this out. Then what I'm going to have is, all right, 3 minus 4 is -1. So this is going to be like having -y is equal to -3. So that's pretty close to being finished, except for the negative sign. So you would divide both sides by -1, and that's going to give you y equals +3. Okay, so that is half of your answer. We still need to know the x value though. So to find the x value, we just need to take this y value and substitute it back in right there. So that is going to give us x equals -4 times 3 plus 8. So that's -12 plus 8. So that is -4. So as an ordered pair, we would have -4, 3. Okay, so that's number 2. All right, for number 3, this is all set up for the elimination method. You see how the variables, the x's are lined up, the y's are lined up. So that is one good reason to use the elimination method. Also, say if we wanted to try the substitution method, the first thing we would look for is a variable that was by itself with a coefficient of 1, so it would be easy to isolate. But look, the x, the y, the 2, the 3, every single variable has a coefficient that's not 1. So this would be very difficult to do by substitution. So that's two good reasons to do the elimination method, also called linear combination. So remember, the key to this method is we want opposites that cancel. That's what we need. So it doesn't matter whether you decide to go after the x's or the y's, as long as we create opposites that cancel. So let's just go ahead and try to cancel the x's. Now for this problem, we're going to have to change both equations. There's no way to turn a 2 into a -5 using multiplication. But if we multiply the top equation by 2, we're going to get a 10. Then we could turn this into a -10. So let's see. So this is going to make 10x plus, I'm just doing my distributive property, plus 8y is equal to 4. Down here, I need opposites. So this is 10, so I need a -10x here. So that's why I'm going to multiply this by -5. And again, I'm doing the distributive property. So that will make -10x, and then -15y, and then -25. A lot of students will forget to multiply the constant at the end and just do the variable terms. Don't forget, when you multiply, you must also multiply by the constant. Now that we have opposites that cancel, I can go ahead and combine like terms. So sure enough, these are going to cancel out. But 8 and a -15 together make -7y. And this is going to make -21. Follow through. Just divide both sides by -7. And we find that y is equal to +3. Okay, so there's our y value. Now, we still need to find the x value. So what we need to do is go back to the original equations and pick one. Doesn't matter which one you pick. I'm going to use the 2x plus 3y is equal to 5 version. It really doesn't matter. Whichever one you pick, you need to take the value that you just found and substitute it where it goes. Okay, so this is going to become 2x plus 3 times 3 is equal to 5. So that's 2x plus 9 is equal to 5. Subtract 9 from both sides. So that will give us 2x is equal to -4. And then divide by 2. So that's going to give us x equals -2. Which means as an ordered pair, the answer would be -2, 3. Okay, that's how we would do number 3. Okay, as I look at this problem and ask myself whether I would rather do it by elimination or substitution, again, look at the coefficients. -2, 5, 4, 3. Every variable has a number in front of it. So this problem would not be a good problem to do by substitution. It would have a lot of fractions and stuff probably. So instead, let's go for elimination. Now, be careful though, because the terms are not lined up properly. Look at this. Let's see. Here's an x term, and there's an x term. They should be lined up. Similarly, okay, all right, fine. The y terms are in fact lined up, so that's good. But as well, the constants, okay, those should be lined up. So we need to get the green ones over here together, the constants. We need to get the x terms together. They should all be lined up. So basically what you hear me saying is this needs to come over here, and this needs to go over there. So how do we do that? Well, for example, to move the 24 over, we can't just move it, but we can subtract it. So we could subtract 24 from both sides. So that would give us, so far, now we have 4y is equal to 3x minus 24. Now we still need to get the x over to the other side. And again, I can't just move it, but I can subtract it. So I could do minus 3x on both sides. That way those would cancel out. So now I would have negative 3x plus 4y is equal to negative 24. Okay, so this is the new version of this equation. This is the one we're going to use. Now, I'm going to sort of start over clean. Okay, so basically what we have is the top equation, I didn't change it at all. So it's negative 2x plus 5y is equal to negative 23. All right, that's just what you see. And now we've rewritten the bottom equation so that we have negative 3x plus 4y is equal to negative 24. So this is what we really are going to work with. Now, we need opposites that cancel. There's no easy way to turn 2 into a 3. We can't turn a 4 into a 5. So this is one of those where we're going to have to do both equations. Just for fun, I am going to target the y's this time. So I am going to make the y's into opposites that cancel. So with that in mind, 4 and 5 can both be turned into 20s. I'm going to make one positive and one negative. So I'm going to multiply the top equation by 4, and I'm going to multiply the bottom equation by negative 5. Okay? So that's going to make the top equation become negative 8x plus 20y is equal to negative 92. Similarly, this equation is going to be positive 15x minus 20y is equal to positive 120. Now, if I combine these like terms, then 15 minus 8 is 7. So this is going to be 7x. These cancel out. And this is going to equal 28. So when I go to divide, dividing by 7, I end up with x equals 4. Okay, so x equals 4. Now I need to plug that back into either one of the two original equations. Okay, I'm going to plug it back into the bottom equation. It really doesn't matter, but so I'm going to take this and I'm going to plug it in right there. So that is going to give me, so I'm going to have negative 3 times 4 plus 4y is equal to negative 24. So that makes negative 12 plus 4y is equal to negative 24. And then I'm going to, excuse me, I'm going to add 12 to both sides. So that's going to give me 4y is equal to negative 12. All right, last step, just dividing by 4. And that's that's going to give me y equals negative 3. So, as an ordered pair, the answer would be 4, comma, negative 3. would be the answer. Okay, that's how you do number 4. All right, the last one, number 5. Substitution. This one is all about substitution. We already have one variable by itself. So that's just begging for substitution. So we're just going to take this and substitute it in for x, which is right here. All right, so if we do that, then this equation is going to become 5 times parentheses plus 10y is equal to -1 plus 6y. So far I just recopied this equation, but where the x was, I put a parentheses because that's where I'm about to substitute. So once again, inside I'm going to put this stuff. So 4y minus 5. So a little substitution goes a long way. So this is going to make 20y minus 25. Okay, picking up from there, it'll be 10y is equal to -1 plus 6y. So look, we got y's all over the place. We have 2 y terms on the left, we have a y term on the right. What I would recommend to you first is combining like terms. The 20y and the 10y, these are like terms. So you should just put them together. They're already on the same side of the equation. So if you put those like terms together, okay, 20 and 10, that's 30. So I've got 30y, and then just bring down your minus 25. Okay, just bring that right on down. Okay, equals -1 plus 6y. After combining like terms, now I would look and I notice I've got the 30y on the left side of the equation, and then I've got the 6y on the right side of the equation. Those two need to get together somehow. But I can't just move them. I need to subtract one of them. So for example, I would subtract 6y from both sides like this. That way these will cancel. So I'm kind of moving it over, but I'm doing it algebraically. So that is going to give me 24y minus 25 is equal to -1. So now it's the time when I would add 25 to both sides, trying to get y by itself. Those go away. So this is going to leave me with 24y is equal to 24. Okay, so now I just divide by 24 on both sides. Those cancel out. So that leaves me with y equals 1. So that is half of my answer, y equals 1. So I need to plug that back in. Let's see if I can fit it. I need to find x way back here. So I need to take this y value and substitute it. So I'm going to take this y value and I'm going to go way over here and plug it in. So that's going to give me x equals 4 times 1 minus 5, which of course is just 4 minus 5, which is -1. So that is the other half of my answer. So as an ordered pair, I would have -1, comma 1. And that is the answer to number 5. All right, that is it for this lesson. Stay tuned for previous lessons. I mean, not previous lessons. Future lessons, we will learn about word problems, real world problems involving substitution and elimination.